Hey, what's up everyone? Welcome back to another video. Before we actually start, I really wanted to share a small experience that I had a few years back. I was looking for a watch. Like other people, I was doing the price comparison across two different platforms. One is Amazon, one is Myntra. I actually added my product to the cart and I was looking for the prices. If there is any drop in the prices, few days passed, suddenly the price got dropped by 20% in Amazon. Then I checked if there is the similar price drop in Myntra. Unfortunately, no. So I went ahead and purchased the product from Amazon. This is not the strange part, by the way. But the strange part is that when I refreshed Myntra tab that I opened in the same browser, just few seconds after my purchase, the price had dropped to the same price that I purchased from Amazon. Is this just a coincidence, or is there a mechanism or a system that is tracking my purchase behavior? Let's find out. Today we'll talk about one of the key core value drivers of any e-commerce platform that you take, which is dynamic pricing. So what exactly is dynamic pricing? It is a way of putting a price tag on your product based on different factors like time, demand, competition, and even user behavior. So companies from airlines and hospitality industry, they have adopted this mechanism since 2010, and nowadays it is a standard way of pricing the products that the company sells. So we'll try to break this video into two different parts. One, we try to understand what are the different levers or factors that is being utilized in this algorithm and how a user behavior is being tracked and utilized for this algorithm and improves its performance over time. Second, we will take a sample data and try to mimic this algorithm, understand in real time how the prices are fluctuating at different point of time. Here, we'll try to segment these factors into three broader categories. One towards customers, another one towards company, and the final one towards the external factors. So when it comes to the customer-centric factors, we'll mostly consider things like the purchase history of the customers and loyalty scores of these customers towards a specific e-commerce platform. And when it comes to the product itself, we'll talk mostly about the demand trends, seasonality especially, which means whether the sale is happening on Amazon Big Festival or a Black Friday event, something like that. Another important driver that is coming under this particular category is price elasticity. So what exactly is price elasticity? Let's assume there are two customers, A and B. Both of them are actually looking for the same product. The customer A is actually waiting for 3 days and the price never changed, and anyway he went and ordered the product. And for customer B, let's assume there is a price drop happening on the third day and immediately the customer places the order. So what is the difference over here? The customer A, even there is no price drop, he actually purchased the product, but for customer B, whenever there is a price drop, he made that purchase. So in simple terms, we can say how much the customer demand changes when the price change. So coming to the company-centric factors, it will mainly focus on inventory-related fields, something like inventory level of each and every product, the nature of the product itself, whether it is a perishable or non-perishable product, certain other fields like capacity utilization of certain storage units, and transportation, logistics, rest of the things. When it comes to the external factors, we'll mainly focus on the competitive pricing because the companies always want to take a competitive advantage of these fields in order to make their pricing much better, whether there is any private label products coming under their catalog. And most important thing is what sort of technology these companies actually use in order to accurately predict the prices of each and every product. Now we have seen few factors that influences the prices of the products in real time. Now it's a time for an experiment. I just want to give a quick disclaimer that this is a purely educational experiment with only public, non-personal data. No laws or platform rules were violated while making this video. Let's start with installing all the necessary libraries that we need. Here I'll be taking very basic libraries that we are going to use for this exercise. Coming to the user-defined functions, I just need only one user-defined function in order to visualize all my variables distribution, how each and every variable is being fabricated. So here comes the data fabrication. So when you see here, I'll be taking whatever the variables that we have discussed previously, something like segment, seasonality, what time of the day the purchase had happened, and days since last purchase. It will talk mainly about how frequent you are while doing these purchases and all. And coming to the supply and operational factors, we talked about the inventory level, capacity utilization, and production cost. And I'll be just randomizing everything and fabricating based on what are the values that is coming out of the library. And coming to the external factors, it will be market positioning, macroeconomic index, everything is random over here. Let's try to run this code and see the distribution. Right, the code run is done and the data frame creation is also done. Let's check the data. If you see here, it will be customer ID, SKU, purchase date along with time. So these things are categorical in nature, and when it comes to the day since last purchase, inventory level, and cross product effect, competitive pricing, and market positioning, and base price and demand, and all these things are numerical variables, and whether it's a categorical, and market positioning is categorical. And yeah, my data frame is now a mix of categorical and numerical variable. Let's try to check the info quickly. So when you see here, we have taken close to 1 lakh records, 100k records, and no missing values because it is completely generated from the library functions itself. So these columns are more than sufficient for us to play around with certain models and certain calculations and see how this engine works in real time. So let's check. So here I am having 4,000 unique customers, and let's check the SKU. That's more than sufficient for us to get started with the codes. Let's quickly explore the different numerical. Here we have seen production cost, inventory level, capacity utilization. These factors are actually numerical in nature. Let's try to look at the distribution, and I'll be removing few of the variables that I feel it should be categorical, like perishability, customer ID. Let's try to get rid of it and check the distribution of other numerical factors. So when you see, it is giving me a quite good distribution, but when it comes to the production cost, competitive pricing, macroeconomic index, base price, and demand, it is somewhere generating a value that is giving me a ideal normal distribution. Right? It shouldn't be. In real time data, it is not possible to have a perfect normal distribution. You can play around with whatever the code that we have used above, adjust the values so that it can give you a very realistic distribution that matches with the real time data. For this experiment, I think this data is fine. Let's try to understand how the engine actually works. Coming to the dynamic pricing engine, so this is a very important module over here. Here I'll be using a class object, so defining all my internal functionalities and calling these functionalities whenever I need. Here the basic declaration will happen for these operations, something like segment elasticity. Whenever I call upon this one, it will directly go and create 3 different buckets for the data. And if I say model, it will directly go and import the linear regression model from the library and rest of the things. Coming to the demand model training, here the model training and predictions will happen. So whenever I am passing a data frame over here, it will do a very basic pre-processing step, and it tries to break it into dependent and independent variable. Here I'll try to predict the demand for each and every SKU that is in my data. It tries to calculate the residuals also. Residuals as in, it is the difference between your predicted value as well as your actual value. If the residual is very high, then your model fit is worst. If it is very close to the actual value, then you are having a very optimal and robust model. So this will happen over here in this particular fit function. Now I have a prediction, and I wanted to bring it very realistic based on certain factors, something like volatility, something like uncertainty factor. I just want to incorporate the impact of the real world into the prediction so that it will become very close to the actual predictions data. When you look at this particular function and see, let's say if it is a score confidence, let's find out where the score confidence is being declared. So here if you see the score confidence function, output will be the algorithmic score and the components. So it is just a value that will tell how confidently you can rely on the particular prediction values. This is how each and every function is being called into the main function. Let's try to run the whole pipeline on our fabricated data and see what are the results that we are getting. So if you see, I'm just calling this object and trying to fit with my data frame. So let's try to run this. So dynamic pricing engine is not defined. Okay, just need to do. So it will take some time because it will go through each and every row item, try to get the prediction values, pass those prediction to the score confidence function, and try to get a value that will tell us whether I can completely rely on the prediction value, whether it is correlating with the real-time instances or not. So now the code run is complete, and let's check the data frame. So this is the final data frame. Let's check that. So if you see, along with the original data, we are having 2 different columns. One is algorithm score. It will give you the confidence whether to trust the predicted results or not. And the second is the adjusted price. Based on the algorithm score, the price will be adjusted. Let's try to check the description of algorithm score. So you can see this is quite a distribution of the score itself. Maximum it can go till 46 or 47% approximately. infinitely, and minimum it can go till 23%. It's halfway. Even the algorithm itself is not able to go till 70 or 80% of the confidence because the data that we fabricated is in such a way. So let's quickly check the elasticity also. So here, like we discussed, there are three different buckets of elasticity. Minus 1.1 is highly elastic in nature, and minus 0.5 is not very sensitive towards the pricing. And these are the different counts that is coming under each bucket. So let's quickly check for different elastic buckets how many SKUs are actually falling in. So here, if you can see, there are 9,000. So let's quickly check the distribution of the score itself. Here you can see there is a very good distribution between 0.35 and 0.45, around 0.4, that is 40% confidence level that the algorithm can throw for the data that we have. So this distribution varies with respect to the data and different sort of SKUs, different sort of base prices that you have. I wanted to check for at least one customer to see how the base price for the SKUs and adjusted price for the SKUs are actually changing based on all this algorithm and calculations. So let's quickly check. This particular line will give maximum number of records across each and every customer. So I'll be taking the customer with the maximum number of records, which means maximum number of times the person had actually purchased. So here I'll be picking up the customer 1743. So I'll be creating a temporary data frame for that person, and let's quickly check. Okay, for this particular person there are 22 items that is falling under most elastic. This person will wait for the price drop for all these 22 different items. Let's go one more step and try to identify what is the sweet spot for a customer. Let's say there are 10 SKUs that are coming under similar price range. What is the sweet spot that actually matches with the perceived value of the customer? This code will bin the adjusted prices and creates average adjusted price and demand curves. Let's try to interpret the results. So initially there are close to 40 SKUs that are coming for this particular customer, and we just took an average. So initially, whenever the average prices are very low, the demand was very high. But when it goes towards the end, the adjusted prices had actually increased. There is a significant drop in the demand. This is a typical example that proves the law of demand, like higher prices discourage purchases. Dynamic pricing doesn't just change the number on the tag, but it changes how we think. Let's say whatever the adjusted prices are actually aligning with the perceived value, it psychologically makes us think that the prices are fair, making us buy more often, and buy sooner. But if we feel the prices are unfair, totally it pushes away. I hope you had a good time understanding how the dynamic pricing actually works, and with this very powerful engine, how these big companies are actually making money. Thanks for watching this video till the end. If you really like the content, just drop a like as a token of support, subscribe, and stay tuned for more videos.